Lots of different ways to solve quadratic sequences. I find the easiest way is to first of all check it is a quadratic. Now I've been told this time, but you wouldn't be in the real thing. So you need to think about finding differences, and you're looking for the second difference to be the same. That tells you it's a quadratic. So the difference between -3 and 12 gives me 15. From 12 up to 37 gives me 25. From 37 up to 72 gives me 35, and so on. I'm going to find the second difference. Between 15 and 25 is 10. Between 25 and 35 is 10. Excellent. So I know it's a quadratic because the second difference is the same. And the fact that it's a second difference of 10 tells me, and this you just got to remember, that it's going to be squared numbers times by half of this. In other words, 5. So I know that the quadratic for this is 5n squared. And then some other stuff. And it's the other stuff that's the hard bit. Now obviously here I've got things to look at I wouldn't have in the real thing. So the way I'm going to do it is work out my squared numbers. So that's just 1 times 1, 2 times 2, 3 times 3, 4 times 4, and so on. I know that this quadratic sequence is 5 lots of these and then some. So now I work out 5 lots of them. That gives me 5, 20, 5 nines, 45, and so on. You only need to do a few to get the thing going. That's 80. So I now do my sequence minus my squared numbers. So -3 take away 5 gives me -8. 20 take away 12. 12 take away 20, so it's always the sequence take away your squared numbers. 12 take away 20, -8. 37 take away 45, -8. Oh, I'm getting -8 each time, and that gives me this bit up here. So to generate this quadratic, it's your square numbers times 5, okay, square numbers times 5, and then take off 8 each time. And I guess if I'd have looked at that carefully, I could have seen that square numbers times 5 take away 8 would give me it. Quadratic sequences, very fiddly.